This is part 5 of the Deriver's review. In problem 16, we want to write the equation of the line tangent to the graph at a particular point. Now, when you see the equation of the line tangent, that means you need derivative, plug in, you need to get a slope, then you can plug in and get a point and write your equation of the line. So let's start off with the derivative. dy dx is equal to, that would be 3x squared minus 6x minus 4 over x as our derivative, because remember that the derivative of natural log is 1 over x, and negative 4 times 1 over x is negative 4 over x. We're now going to plug in the 1. So dy dx at x is 1 is equal to 1 squared minus 6 times 1 minus 4 over 1. That's going to be 3 minus 6 minus 4, which would be negative 7 as our slope. We now need a point, so let's go ahead and plug in the 1 into the original problem. Y equals 1 cubed minus 3 times 1 squared minus 4 times the natural log of 1. So we have y is 1 minus 3. Now we need to remember from Algebra 2 that the natural log of 1 is 0. So this term just falls away, and y is negative 2. So now we have a point, 1 comma negative 2. We can now use point slope form. Y minus y1 equals m x minus x1. We can plug in our values, so we have a y minus a negative 2 is equal to a negative 7 times x minus 1. Clearly the double negative can make a positive there. We could convert to other forms if we needed to. In 17, we're writing the equation of the normal line. Normal line is like the perpendicular, so we would need the negative reciprocal of our slope. So let's start with the derivative. F prime of x is equal to, now we want to think of this as being squared out there, so we've got the derivative of the outside, don't change the inside, multiplied by the derivative of sine, which is cosine. We're plugging in a pi force, so f prime of pi force is equal to 4 times sine of pi force times cosine of pi force. So 4 sine of pi force, root 2 over 2, cosine of pi force, root 2 over 2. So this 4 would cancel out with the 4 on the bottom there, so we get root 2 times root 2. F prime of pi force is then clearly just 2, which is our slope. We now need a point. We have pi force as our x value, we need a y value. So let's plug into the original, so we have f of pi force is equal to 2 times sine of pi force squared. So 2 root 2 over 2 squared. That would be 2 times 2 force. Clearly that would be 1. So we have pi force, comma 1. So y minus y1 equals mx minus x1. If we plug in the values, we get y minus 1 is equal to 2 times x minus pi force. In problem 18, we have product rule. So there's my first function, there's my second function. We need to go f times g prime plus g times f prime. dy dx is equal to first function multiplied by 1 over x plus the second function multiplied by 2x. We can do a little canceling over here. So dy dx would be x plus 2x natural log x. In problem number 19, we have a chain rule here and a chain rule there. This is also an a to the x function. So we have dy dx is equal to derivative of sine is cosine. Don't change the inside. Multiply by the derivative of the inside. Plus a to the x would be a to the x natural log a multiply by the derivative of the inside function, which would be cosine x. Probably the only thing we could do is move that 2 out in front, and then we'd be done.